I've already translated our system of equations in example 11 into an augmented matrix. Again, we can see that we need to start off by turning that value in row 1, column 1 into a positive 1. So in order to do that, we'll update row 1 by taking negative 1 times all of those values in row 1. Our values in rows 2 and 3 will stay unchanged for now. But then we'll look at zeroing out each of those values below that positive 1 we created. We'll update row 2 by taking all of our values in row 1 plus all of our values in row 2. Or we could think of this as taking 1 times those values in row 1. We'll update row 3 by taking negative 7 times our values in row 1 and adding that to row 3. The first value in each row will zero out, and we'll update the remaining values in each row. Our easiest approach in this case to turn row 2, column 2 into a 1 will be to replace row 2 and row 3, or to switch the places of those two rows, since row 3, column 2 is already a 1. So simply by switching rows, row 2, column 2 is a 1, and now we'll look at zeroing out that value below it. So we'll update row 3 by taking negative 4 times row 2 and adding that result to row 3. The 0 will remain unchanged. That value of 4 will turn into a 0, and the rest of the values in that row will also become 0. In this case, looking at that third row, we can translate that back into the equation 0 is equal to 0, which is always true, meaning we have infinite solutions, or a dependent system. Our value for z can be any number that we want, and then we need a way to define x and y in terms of that value z. So we'll need to work our way back through equations 1 and 2. We'll start with equation 2, which tells us that y minus 3z has to be equal to negative 7. Or solving for y, we'll get negative 7 plus 3z. Looking at equation 1, we have x minus y, which is negative 7 plus 3z, minus z is equal to 1. We could distribute the negative sign through and solve for x to obtain x is equal to 4z minus 6, which will allow us to write our solution as the infinite set of ordered triples x, y, z, such that x is equal to 4z minus 6, y is equal to negative 7 plus 3z, and z is any real number. So again, telling us that what we can do is choose any value for z, we can pick any number, and then generate the corresponding values for x and y using those equations, and we're guaranteed to have an ordered triple that makes all three of those equations true.